Good morning, mathematicians. We are looking at week 2, and we're going to be working on the Monday column. We're going to see a lot of equivalent fractions today, but remember, boys and girls, all of this is a review of 4th grade content that is going to be very important to our priority standards in 5th grade. So we're starting here with thinking about using a model or a number line to prove the following is true. 2/5 does equal 4/10. So how could we show this? Well, right away, my mind goes to thinking about a model, right? If this entire model is equal to one whole, could I start with showing 2/5? Certainly I could. Let me separate this into 5 columns. Here I now have 5 columns, 1, 2, 3, 4, 5. I can highlight 2/5. Here's 1/5. Here's 2/5. So I have shown 2/5 here. Now I can divide this in such a way as to create 4 from this and 10 from the entire thing. Of course, how can I show that? Well, I can show that right here with a horizontal division. Now I'm seeing my whole is broken into 10 rectangles, and I have 4 of those rectangles still highlighted. So in this way, boys and girls, we have proven that 2/5, which I see in 2 of my columns, out of 5 columns being highlighted, I have proved that that is equal to 4/10 because I also can show that I have 10 rectangles in my whole and 4 of those are highlighted. I have proven this equivalent fraction equation. Let's go ahead to the next one because here we're going to be proving equivalent fractions as well, but now we're proving it with a number line. This says label the number line with thirds and sixths. Show that 2/3 equals 4/6. Well, let's begin with dividing this to show 2/3. Well, if I want to show 2/3, I'm going to have a third about here and I'm gonna have my 2/3 about here, right? Because in the way that I've divided this, I have shown a third, a second third, and 3/3, right? Now, again, that's eyeballing it. It's not perfectly even, but it's good enough for me to prove my equivalent fraction. Now, if I want to further divide each of these partitions in half, I could show 6. Now I have shown 1/6. This is also 2/6. Now I could divide this to show 3/6. Here I have 4/6. Here I have 5/6. And here I have 1 whole or 6/6. So in this way, once again, we have proven that these two values are equivalent. Because remember, boys and girls, equivalent fractions fall on the same point of a number line. And certainly here, they do just that. Let's go to our next one, where we are going to be using a model to show equivalent fractions, but we're also going to build an equation. I love this one because this does show us exactly what is happening when we change that numerator and denominator to an equivalent form. This says show that 3/4 equals 6/8 using the area model and multiplication below. Well, first of all, I see right here 3 out of 4 columns shaded. I have 1, I have 2, I have 3. So I see 3/4 here, right? Now they want me to show how it also can equal 6/8. So with that, I know that that is the equivalent fraction that I am wanting to get to, right? Now, similar to how up here I divided it by splicing it in half, partitioning it in half, I'm really going to do the same thing here. Because if I partition it in half, I have not changed the shape of the shaded area. What I've done is I've given myself 2 in place of the 3 columns shaded. Now I have 3 columns shaded, but also 2 rows, right? And notice, boys and girls, I have to treat the numerator and denominator fairly, but notice I've multiplied them both by the same value. That value is 2. 3 times 2 is 6, and 4 times 2 is 8. Now I also see that 6 out of my 8 rectangles are shaded. So I know that 3/4 equals 6/8. That's what I'm after in this problem. Let's take a look at our next one where we are thinking about some farm animals. 3/4 of Old McDonald's farm animals are shivering sheep. The rest are chili chickens. What fraction of Cole McDonald's farms are chili chickens? Well, I know by these fractions that he has 14 animals in all. Now, the 14 animals are sheep and chickens. I just need to figure out how many are chickens. Well, 11 of the 14 are chickens. So how many, or excuse me, 11 of the 14 are sheep. So how many are left to be chickens? Well, 11 minus 14 gives us a leftover or a part of 3. So we know that 3 are chickens. 11 plus 3 is 14. That accounts for all 14 animals. So we're going to say that 3 out of 14 are chili chickens. And in this way, once again, if my question has words and context, my answer should as well. So my answer here is tying it back to the 3/14 are accounting for the chili chickens. One more question for today, boys and girls, and we are comparing. In math, when we hear compare, we think less than, greater than, or equal to. Now, we are thinking here about 2/5 and whether that is greater than, less than, or equal to 7/10. We can use equivalent fractions to do this with the surety. So, first of all, I'm going to start with this 2/5, and I'm going to change it into an equivalent form that also has a denominator of 10, like my 7/10. Well, what do I do to the 5 to get to 10? I multiply it by 2. 5 times 2 is 10. So I can multiply my numerator by the same value of 2. 2 times 2 is 4. So I know that 2/5 equals 4/10. And this way I can clearly see that 4/10 for sure is less than 7/10. So I'm going to put a less than symbol here. And for my final answer, I can put a less than symbol here. Now let's go to our next one. We have 3/10 over here. And I want to know if that is greater than, less than, or equal to 1/5. But just similarly to what we did above, let's go ahead and turn this into an equivalent value. I have 1/5, but I want to know what that equals as an equivalent fraction with a denominator of 10. Well, 5 times 2 is 10. So I'm going to do the same thing here and multiply my 1 times 2, which is 2. 3/10 for sure is greater than 2/10. So I'm going to put a greater than symbol there. Now, boys and girls, I'm looking at 3/4. And I want to know if that's greater than, less than, or equal to 7/12. Okay? So I'm going to turn my 3/4 into an equivalent fraction with a denominator of 2, or excuse me, with a denominator of 12. So what do I multiply 4 by to get to 12? I multiply it by 3. 4 times 3 is 12. Well, 3 times 3 is 9. 9/12 is larger or greater than 7/12. So I'm going to plug